Hello, this is the first semester final review for geometry. I'm going to go through each of these problems on the review, and just so you can check your answers and know if you're doing everything right, but make sure you can go back and do everything on your own before you take the final. All right, let's get started. Our first unit, we had started with the distance formula, so we can just find how far it is from 2 points. And there's a couple ways of doing this, one with a graph and one without. So the first with the graph involves finding the rise and the run between the 2 points. So we can count here and see this is 7 across and 2 up. And we're going to use Pythagorean theorem really to find out what c squared is, right? So instead of c though, we call it d for distance. So d is going to be the square root of a squared plus b squared. So this will equal root 49 plus, 7 squared is 49, 2 squared is 4, so 49 plus 4 square root equals the square root of 53. And we can leave our answer in this format. Okay? So again, we just find the rise and the run, basically. So this has a rise of 1 or negative 1. And this has a run of 1, 2, 3, 4. So the distance from this point to this point will be the square root of 1 squared plus 4 squared, which equals 1 plus 16, which is just root 17. Okay? So that's how we use this, find the distance using the graph. Now, without a graph, you can actually sketch it, or we're going to use the same formula here. And all these numbers are is how far is it from here to here? So how far was it from negative 1 for x to positive 3? And we can figure out, well, they're 4 apart. So we can do the same thing without a graph. We can ask ourselves, how far is it from 4 to 5? And of course, that's only 1 apart. So that'll be 1 squared. And we can do the same thing with the y values. Ask ourselves, how far is it from 3 to negative 2? And those would be 5 apart. Okay? So we can get the same answer just by asking ourselves, how far apart are the x's and the y's from each other? So we'll have 1 plus 25, and which is the square root of 26. Okay? And one more time. Okay. So how far is it from 3 to negative 6? That would be 9 apart. And how far is it from negative 6 to 3? Of course, that would be 9 again. So we have 9 squared plus 9 squared, which is just 81 plus 81, which equals the square root of 162. All right, so that is the distance formula, which is basically the Pythagorean theorem, a squared plus b squared equals c squared. Next, we have the midpoint formula. So we want to know what is the middle coordinate. Right? So there's a couple ways of doing this. First thing, though, we need to know what the coordinates actually are. So this one is negative 3, 4. And here we have 0, 5. So we want to know what is the coordinate that's right in the middle. You can kind of guess what it is, like negative 1.5 and maybe 4.5. But we can do this officially by finding the middle or the average of each the x's and the y's. So ask yourself, what is the middle of negative 3 and 0, right? It's like in the formula we call this x1 and x2. And we just want to find the average of them. So we're going to add those up and divide by 2. That will give us the middle of those 2 points. Now, negative 3 plus 0 is negative 3. Negative 3 divided by 2 is simply negative 1.5 or negative 1.5. So that is the first coordinate. Next we can do the, go green, we can do the same thing but for the y coordinates. What is the middle of 4 and 5? You can probably guess 4.5, but we can show that by, once again, adding those up and dividing by 2. So we have 9 divided by 2, which is 4.5. So this is the middle or midpoint right here, which we could probably just estimate by looking at it. This is -1.5 and 4.5, but we want to be able to show it as well. All right, so let's do it again. This time we have a coordinate 1, 0, and this is the coordinate 2, -2. All right, and to find the middle of the x values, what is the middle of 1 and 2? Again, you can probably guess that's 1.5, but we can always show it. 1 plus 2 divided by 2, right, which is 3 over 2. 3 divided by 2 is 1.5. Then we can do the same thing for the y values. What is the middle of 0 and -2? You could probably guess that's -1, but we can show it by adding 0 plus -2 divided by 2, which is just -2 over 2, which is -1. Okay, so both these we can kind of guess by looking at the graph and calculating what the answers are. So when there is no graph, we'll just do the same thing. So for the x values, what is the middle of 2 and 1? So 2 plus 1 and divided by 2 to find the middle. All right, so 2 plus 1 is 3. 3 divided by 2 is again 1.5. Seems to be popular. And then for the y values, what's the middle of 4 and 0? So the middle of 4 and 0 is probably, you can guess, is 2. If not, we can just add them up and divide by 2 and get the answer that way as well. Okay. And one more time, just to get enough practice. What is the middle of 6 and -8? A little more difficult to figure that out in your head, so that's why we have the formula. 6 plus -8, divide by 2. 6 minus 8 is -2. -2 divided by 2 is -1. And then for the y values, what is the middle of -3 and -1? Probably guess the middle of those two numbers is -2, but we can show it by adding them together and dividing by 2. So -3 and -1 make -4. -4 divided by 2 is -2. Okay. So that is the distance and midpoint formulas. Very first problems we started with this year. Next, we have segment and angle addition. So here we have to be very careful knowing what we're trying to solve for. So sometimes it says solve for x or find the distance of a particular segment. Same thing with the angles. Sometimes it says find the measure of an angle. Other times it says find x. So be very careful of what you're actually trying to solve for. Second, you'll notice I color-coded everything all in the same way, where the two smaller pieces, the red and the blue, always add up to equal the larger piece. And this is where we break the problem. So keep that in mind. On all of these segments and angles, we always have two small angles and then the large angle, okay, or the wider angle. So usually two, sometimes an acute obtuse and then a very big obtuse angle. So with the segments, we just have to have this in mind, and we can do, well, the red or TU is going to be 6. The blue here, the other small, is going to be 2x plus 21, and that'll add up to the large measurement, the whole length, which is x plus 19. And then we just need to solve this equation to find out what x equals, and that's all we need to do on this problem. So we'll have 2x plus 27, when you add the 21 and 6 together, is 27. And then we can subtract x on both sides and subtract 27 on both sides. Okay, so subtracting x on both sides gives us x, and subtracting 27 from 19 gives us -8. Okay, so here x equals -8, and that is our final answer. All right, same idea here. We have a small segment and a small segment here, and then we have the full length. So we have x minus 4 plus 7 will add up to 2x minus 2. So we have x minus 3, sorry, x plus 3, -4 plus 7, 7 minus 4 is 3, equals 2x minus 2. And we can subtract x on both sides, so we'll get x. Add 2 to both sides, so we'll get 5. So here x equals 5. Okay, last one. We'll have x minus 6 plus x minus 1 will add up to 17. So we have 2x minus 7 equals 17, which means 2x will equal 24 when we add 7 to both sides, which means x equals 12. Okay. Next, let's do the angle addition. So you notice I color code these ahead of time to make it a lot easier to know where everything goes. So I know I'm trying to find this as my final angle measurement. I know that the red one, this is going to be 48, right? And the large angle, the full big angle, is 168. Right? So since we're looking for this, I'm just going to call this x. So that means 48, small angle, plus the other small angle, x, is going to add up to 168. There we go. And we can just solve this by subtracting 48 on both sides. So x will equal 120 degrees. Right? And that's also the measure of THI. All right, next we can find x again. So QRM, the red here, this is 19x plus 5. The blue is 40. Okay. And then the full large angle is 24x plus 10. So the blue, or the red plus the blue equals 24x plus 10. So slightly bigger equation to have to solve. So we'll have 19x plus 40 equals 24x plus 10. I'm going to subtract 10 on both sides, so I'll get 30. And I'll subtract 19x from 24x, and that will give me 5x. And divide both sides by 5, so x will equal 6. But remember, we're trying to find x here. Okay, so we are done. So that's our final answer. Always checking to make sure we got the real answer. The last one, we have the red, which is 44. We have the blue, which is 13x minus 3. And then the big angle here, which is 18x plus 6. All right, so we have the red, 44, plus the other small part, 13x minus 3, should add up to 18x plus 6. So just solve this, we'll have 13x plus 41 equals 18x plus 6. And looks like we're going to subtract 13x on both sides. So 18 minus 13 gives us 5. Subtract 6 on both sides. So we'll have 41 minus 6, which is 35. And then divide both sides by 5, and we'll have x equal to 7. Okay. Now the question says to find the measure of this angle. So this is not the final answer. So our final answer will be the measure of HDE, which is 13x minus 3. So, and now we know x equals 7, so that's going to be 13 times 7 minus 3. And 13 times 7 will give us, what is that, 91. 91 minus 3 is 88. Okay. Degrees. There we go. So this is our final answer. Measure of angle HDE is 88 degrees. So always checking the description here to find out exactly what we're solving for. All right, let's go down. And on the next page, we have midpoints of segments and angle bisectors, which are kind of the same concept. They both involve something that cuts it down the middle in half. So for here, it says we have M is the midpoint of PQ, so that means PM and MQ are congruent on both of these. So good to draw the diagrams here. Right? Then we can just label them. Right? So MQ right here is 5x plus 8. And we know the entire segment here to here is 6x plus 56. Okay? So like before, the two smaller pieces add up to the big piece. Now these are both the same color because they are midpoints, which means these are identical. It doesn't tell us what PM equals because it's the same. Right? So works just the same. These two add up to the big. Right? Now, since these are the same, we usually just write them as 2 times. You could say 5x plus 8 plus 5x plus 8, but it's a little easier just to say we have 2 of them. That adds up to 6x plus 56. Okay? So a little bit of algebra. We'll have 10x plus 16 equals 6x plus 56. Okay. Subtract 6x on both sides. 10 minus 6 gives us 4. And 56 minus 16 will give us, let's see here, 40? Yeah, 40, which means x equals 10. Okay. Now, like before, check to see what you're solving for. The question says find PM. So x is not our answer. PM is 5x plus 8 because it's the same as MQ. So one last step to find PM. It's going to be 5 times 10 plus 8, which equals 58. So that is our answer, PM. Of course, MQ is the same, 58, which means the whole length would be 116. Okay. Number 16 is very similar. So PM is 6x plus 7. Okay. MQ is 9x minus 8. So this is slightly different. It doesn't give us the length of the entire segment here, PQ, because it's a different type of problem. Remember over here how these two are the same? So these are equal to each other, right? 5x and plus 8 and 5x plus 8. So these are equal to each other as well. So we just set them equal to each other. So there's 2 types of midpoint problems. There's the type where they give us the 2 small segments and they're equal to each other. And there's the type where they give us one of the small segments and the whole length, and we just have to double one of the small ones. So we can subtract 6 on both sides, so we'll have 3x. Add 8 on both sides, which is 15. And divide by 3 on both sides, so we'll have 5. And once again, check to see what we're actually solving for. So this time PQ, that is the length of the entire distance, right? So we can do it a couple ways. We can find the length of one of them and then double it, right? Or just add these together and figure out what that is. And that's what I'm going to do. So PQ is 6x plus 7, right? And 9x minus 8. So we'll have together 15x minus 1. And once I solve or substitute in 5, we'll have 15 times 5 minus 1. So do the arithmetic here, and your answer should come out to be 75 minus 1, which is 74. 74. That is the length of the entire. There's a couple ways of doing it. This is just one. So if you get 74 a different way, that's just fine. Okay, now let's do the same thing, but with angles. So instead of calling it midpoint, they call it a segment angle bisector, right? So bisects an angle. So that's an angle bisector. So these two angles are congruent, much like these two segments are congruent. Same exact idea. They're both the same color because they're both going to be the same measurement. So here we have, let's see here, CDF. Which is 2x plus 1. We have FDE, which is 3x minus 7. And we just have to solve for x. So this is very similar to 16, where they gave us the two small segments. And since this is the midpoint, they were equal to each other. So they give us the two small angles, not the whole big one. So these two are just equal to each other. So much like the last problem, set them equal and go ahead and solve. So subtract 2x on both sides, just get x. And add 7 to both sides, get 8. And our directions are just to find x, and we have done that. So that is it, real fast problem. Okay. The next one here actually gives us the whole big angle, kind of like here where we got the whole segment. So we have ABC is the whole, this is A, and this is B, this is C, I think this is D. ABC is what we're is being bisected, and that is equal to 76 degrees. And DBC is 4x plus 6. Okay. Now, much like over here, they did not give us what PM equals, but we knew it's the same thing because this is the midpoint. This is the same as this because it's a same angle. So this is also 4x plus 6. And like we did before, these two smaller angles will add up to the large angle. And I can just do this, say 2 times 4x plus 6 equals 76. Okay. So we can divide both sides by 2. So 4x plus 6 will equal 38. Subtract 6 on both sides. And we'll have 32. And divide both sides by 4. So we'll have x equals 8. All right, and that's our directions to find x. And we've done that, so we are finished. So these two are very similar in how we solved them, and these two are very similar. One with segments, one with angles. Okay, the last part of this Unit 1 review right here is these three problems. And these were called linear pairs, where just two angles added up to be a straight line. So in this case, unlike the segment and angle addition, they don't need to give us what the straight line equals. They're always equal and adding up to 180 degrees. So for each one of these, anytime you have a straight line involved, again, that's called a linear pair, and you can remember it this way. Linear pair add up to 180 degrees, always. Each of these, without being told in the description, unlike the problems above, we just have to know that it adds up to 180. Okay? And then it's just a matter of the two smaller parts adding up to the big part, which is 180. So we have 44 plus 3x plus 1. All right, so 3x plus 45, 180. Subtract 45 on both sides, so we get 135. So divide both sides by 3, and we'll get 45 degrees. Oh no, just 45. And we're trying to find x, so we are finished. There we go. Same thing here. Got two angles that add up to a straight line. So the two smaller angles are 4x and 84. to add up to 180 degrees. So just subtract 84 on both sides. So we got 4x equals, would be the 96, and divide both sides by 4, and we'll have, I believe that is 24. Yeah, there we go. And that was the directions. Okay, and one last here, we have ABC, okay, which is the red, 5x plus 12, and then CBD, which is 3x. So these just add up to 180 degrees, a straight line. So 5x plus 12 plus 3x. So that's 8x plus 12 equals 180. Subtract 12 on both sides. We'll have 168. And divide both sides by 8, and we'll have, let's see here, 8 goes into 16 2 times, 8 goes into 8 1 time, x equals 21. And that was our directions to find x, so we are finished. Okay, so that completes the review for Unit 1. We have distance formula, midpoint formula, segment addition, angle addition, and then linear pair formulas.